So number 1, let g be the function given by g of x equals x squared e to the kx, where k is a constant. What value of k does g have a critical point at x equals 0? Well, we know we find critical points by using the first derivative test, or actually we find the derivative and set it equal to 0, and that's how we find our critical points. So here is g of x, so what's g prime? So g prime of x, well, we'll do the product rule, and so x squared is 2x, and this is a constant, so derivative of e to the something is e to the something times the derivative of something. Since this is a constant, we have k e to the kx. And so let's put that together. So this times this, I have k x squared e to the kx, right? This times this plus this times this. 2x times e to the kx. And so I need to set this equal to 0. So 0 equals, I would like to, let's factor here, because if I have two factors, I can tee off and solve. So GCF, there's an x here, and an x here, and e to the kx, and e to the kx. So we have this times k is still here, there's still an x here, but this was taken out, and what's over here plus just 2. And so when I have something times something equals 0, I can tee off. And so this side, I get x equals 0, right? That's the only way that this will ever equal 0. X equals 0. If I do this, that just gives me x equals 0. That doesn't really help me. I'm looking when x could be 2/3. So let's look at this side. Here I have kx plus 2 equals 0. Kx equals, I'll subtract 2 to the other side, divide by k, x equals -2 over k. Well, I want to know what value of k will give me x equals 2 over 3. Well, if this is -2, in order to get positive 2/3, I need k to equal -3. Negative over negative is positive. So as soon as I see critical point, I know I take the derivative. I set the derivative equal to 0. I go ahead and solve it. Here I just got x is 0. Here I got it in terms of k, and so I can easily figure out what that is. Or I could have then set this equal to 2/3, whichever. Number 2. So here I have, it's a limit. So I know first I would plug in 0. But if I plug 0 into here, then I would get sine of pi over 3 minus sine of pi over 3 would be 0. Plug in 0 here. So once I have 0 over 0, I know I can use Lhopital's rule. And so Lhopital's rule says to take the derivative of the top and then take the derivative of the bottom with respect to whichever variable is here. In this case, it's h. So sine of something would be cosine of something times the derivative of the inside, which this is a constant, this is h, so this is 1, minus sine of pi over 3, that's a constant. There's no h in here, so this is just some number, so this is 0. All over, well, this is h, this is 1. And, well, this is just 0 divided by 1. Really, I just need to focus on this piece of it now. I plug in 0 for h. I'm left with cosine of pi over 3. And what is cosine of pi over 3? Well, pi over 3, if you don't know radians off the top of your head, you should know that pi over 3 is equal to 60 degrees, right? Because I take pi over 3 and I multiply that by 180 over pi. So my pi's cancel. 18 divided by 3 is 6 and 0. So this is the same as cosine of 60 degrees, which equals 1/2. Final answer, 1/2. And just quickly, let's remember, you need to know this, right? If I have 30 degrees, that's pi over 6. If I have 45 degrees, that's pi over 4. If I have 60 degrees, that's pi over 3. And we do sine, cosine, tangent. If you know how to develop this, you'll remember without a calculator. It's 1, 2, 3, 3, 2, 1, 33, 13. You need to know these exact values. You need to know these exact values.